These are some problems from our 18.0a assignment, Special Right Triangles. Mostly I chose even ones because I published the odd ones for you to check your work. But sometimes there was just an odd one that hit me that I really wanted to look at. So the first thing is always look at the triangle. Decide if you have a 45-45-90 triangle or a 30-60-90 triangle. And this assignment will always be one or the other. The first ones I see here, this has a 45, this has a 45. I know that that's a 45-45-90 triangle. So I'm going to say which sides are which. I'm looking at this. This is my 45-45-90 triangle. We always just say 45-45-90, but technically those are the degree measurements of our angles. I see that this first one has two matching sides. They called this one N, and even though they called this one M, it's also N because they match each other. And this one is our N root 2. Because I see N root 2 side is 5 root 2, I'm hoping that you can recognize that will only work if we get N equals the 5. That is our N side. And since in this problem they've labeled that one M, I need to also say M equals 5. I didn't really have to show any work for that one at all. And there's no need to write down this side because it was already given. They just want to know what's N, what's M. Pretty easy. I needed to do one of the really basic ones because on the last assignment somebody, on 17.1a for instance, somebody mentioned that I didn't do anything like 1 and 2, and I went, it's the same thing, only easier. So this time I had to show you one of the easy ones. If I look at number 7, it is also a 45-45-90 triangle, which means this is my basic N side, and so is this, because those meet to make the right angle. And then my hypotenuse over here is my N root 2 side. The side that I know is 2 root 10. And since it has to match this guy over here, I'm going to write down that B is also 2 root 10. But my A side has to be that times root 2. So my hypotenuse has to be N root 2. But I know that my N is 2 root 10, and I need to take that times an extra root 2. So now I have 2 square root 20. But I'm not allowed to leave my radical 20 if it can possibly be split up. So let me think about, circle that before I lose track of it. Think about 20 being split. I'd say 2 times 10. I'd say 5 times 2. I see a pair of 2's, which gives me a 2. And I see a leftover 5, so I have root 5. But the thing I need to remember here is that's the root 20 part of it. I still have this other 2 that was already there in front. So now I have 4 root 5. And that is my hypotenuse. And if I go back up here, my hypotenuse was my A. So I have 4 root 5 equals A. Let's look at number 10. 60 degrees this time. If it has 60 degrees in it, we're going to have to deal with the other pattern. And the other pattern up here is my 30, 60, 90 pattern. And again, we say 30, 60, 90 all the time, but it's really 30 degrees, 60 degrees, 90 degrees. Since you're not putting that in writing, it doesn't matter that much. Okay, shortest side of all. Well, the medium-sized side is opposite from the medium-sized angle. So I like to remember these two patterns by saying the one that has 45, 45, 90, just two different sizes of angle, also has a root 2 involved in it. The one that has 30, 60, 90, three different sizes of angle, also has a root 3 in it. I think I messed up one of those on the notes and then had to fix that. So think about this. Does this one have three different sizes of angle? Yes, 30, 60, and 90. And it has three different sides, and it has a root 3 in it. The shortest side is the B side. The longest side is the hypotenuse. That's my 2n. And this one down here, that's my n root 3. It's got a root 3 like it's supposed to. So technically, I guess that you could get away with not showing work on this one if you can see it easily. Most of us don't see it so easily, so let's see what we can do to work this guy out. I want the root 3 by itself, and my first thought is divide by root 3 on both sides. But you can see how awkward that looks. So when you're dealing with fractions, instead of dividing by root 3, it's probably easier to multiply by 1 over root 3. Basically, reciprocal. Multiply by the reciprocal instead of dividing. So over here I'm going to multiply by 1 over root 3. That means I've got a root 3 here and a root 3 here that I can get rid of. I've got a root 3 here and here that I can get rid of. And I'm left with just n on this side and 5/2 on this side. That's one of the sides I want to find. I want to find the n side, the shortest side first if I can. In this case, that's my b. So I'm not going to circle n equals 5/2. I'm going to circle b equals 5/2. And then I need the hypotenuse. And the hypotenuse, once I found the b, should be much easier. The a side is my hypotenuse, and my hypotenuse has to be 2 times what we just got for n. 2 times 5/2, 10/2, or cancel it and just call that a 5. A side, B side, found both of those. Originally I had n root 3 equals 5 root 3 over 2. If I had looked at that as n root 3 equals 5/2 root 3, maybe I would have been able to see right away that I could get rid of the root 3's, and I would have had n equals 5/2. It would have saved some time, so maybe technically if you saw that right away, you wouldn't have to show any work. But here, I had to show you some work. Here, no work required, but it's okay if you wanted to do some work. Let's look at the next examples. Number 12. Looks like another 45, 45, 90 triangle. Except that hypotenuse is supposed to have a root 2 on it. Leg, leg, and root 3 for the hypotenuse. It's supposed to have, I wrote root 2 again when I meant root 3. Two sides of angle, root 2's in it. I'm going to bring it down here and write myself a little equation that says n root 2 equals 3. Want the n by itself, so I divide out the root 2. And now I have n equals 3 over root 2. But we're not going to be leaving any radicals in the bottom. I often say not allowed in the bottom. It's not allowed in the bottom in these problems. My husband, who teaches calculus, says sometimes it's better to leave them in, sometimes it's better to get rid of them. For now, we're practicing how to get rid of them because it will be so easy later to learn how to leave them in that we need to learn how to do. I want to get rid of root 2, so I multiply the root 2 on top and bottom. So now I have the inside equals 3 root 2 over 2. And I really can't just reduce the 2 that's inside a radical with the 2 outside of the radical. So that's my inside, but I'm not going to circle that equal to n. I know that's what n is, so I'm going to write equals y before I circle that. And guess what? X should be the same thing. So I'm also going to write 3 root 2 over 2 equals x. And x and y were the only two sides I had to find there because the hypotenuse was already given. With a 45, 45, 90 triangle, you're going to have roots in there somewhere. It might be both legs have roots, or it might be the hypotenuse has a root. It's going to be in there somewhere. The same thing with 30, 60, 90 triangle. If you're finding all three sides, it's going to be in there somewhere. One of them has to have a radical, sometimes more than one. 14 is an example where we have two triangles stacked on top of each other, sort of. A 45, 45, 90 triangle and a 30, 60, 90 triangle. I think there are just two of those in the A assignment, but there are quite a few more of those in the B assignment. So you'll have just one odd one to work out by yourself. Here we go. I need to find x. And x is a side in the big triangle. If I look at the big triangle, then that big triangle, it's a 30, 60, 90 triangle. So I've got a 60 and a 90, so I know it's a 30, 60, 90 triangle. And I want to find the hypotenuse. Unfortunately, I don't know any of the sides in that triangle. The only way I'm going to figure this out is if I can first find this side where the true triangles meet up with each other. Okay, so if I look at the little triangle here, it's a 45, 45, 90 triangle. They didn't put letters all over the place like they did in the first problems, but I know these two legs have to be the same. So if one's a 5, the other one's a 5. And the hypotenuse has to be the leg, the short side there, times root 2. So I'm going to say this piece that where they join together is a 5 root 2. You see that one without any work? Whole number, and then that same whole number times root 2. Now I can look at my 30, 60, 90 triangle. And on this one, I think I'm going to go ahead and put in some letters because it'll make it easier to see what's going on. Where I have a question mark because I needed to find that, that is my short side. I'll label it N. And my longer leg, N root 3. And my hypotenuse, 2n. I don't really care about the long leg this time because they only asked me for the x one. So I'm going to say that my x side is 2 times whatever that short leg is. And that short leg is 5 root 2. So 2 times 5 root 2 means that I'm going to end up thinking my x is 10 root 2. Nothing I can simplify. That becomes my final answer. Those triangles stacked on top of each other, there are only two in this assignment, number 13 and number 14, so I left you one to do for yourself. But when you get to the 18.0b assignment, there's more, maybe 6 of them. Let's go to this last page. I'm going to do a little setup on both of these, but I don't think I'm going to finish them off. You may remember from our notes, in our notes we figured out the area of an equilateral triangle was the side squared root 3 over 4. So in this case, they told me that this is 10, and this is 10, and this is 10. Those are meters. And we could do what we did in the notes, where we draw this in, and we do this, and we do half the side, and we do the root. We don't need to. We have a formula now. So I have 10 squared root 3 over 4. Make sure that line goes all the way to the end. I don't like it when your fraction bars come out short. Which means I have 100 root 3 over 4. And 104 can reduce. So that I just end up with 25 root 3 in meters. And since it's an area, make it meters squared. That's all. We didn't have to go through all the stuff we went through in the notes. That's why we did it in the notes, so we could make ourselves a formula that we could use. Let's look at 15. 15 says the area of a square with a diagonal of length root 14. And I want you to remember that the formula for the area of a square equals the base times the height. And I don't know the base and the height yet, but they told me the diagonal is the square root of 14. Remember from our notes that a square has 90-degree angles, and at the corners where the diagonal comes in, those are split into 45 and 45. Down here, 45 and 45. Technically, those are 45 degrees. If it was part of your answer, it better show the degrees. But it's not part of our answer, so I'm not that worried about it. In a 45, 45, 90 triangle, the two legs, the short pieces, come together to form a right angle. And then the hypotenuse is the short side times root 2. So I'm going to pull this out of the shape and say I have a formula. N root 2 equals square root 14. Now you might try and split up square root 14. It doesn't end up splitting, but in any case, I probably wouldn't worry about it yet. I'd say, how do I get the n by itself? Divide by root 2. Divide by root 2. And because those are both roots, I can do root 14 divided by root 2 is root 7. Now that's not the answer to my question, so I'm not actually going to circle it. I'm just going to put it on the sides of my square. This is root 7, and this is root 7. So if the formula for the area of a square is the base times the height, I'm going to do root 7 times root 7. And if you wanted to write down a step that says root 7 times root 7 is root 49, you could do that. But it's not required because by this time we should know root 7 times root 7 is going to be plain 7. Just like we know square root of 36.97 times the square root of 36.97, 36.97. We know that the square root of x times the square root of x is the square root of x squared, so it's just x. We don't have to show work for that, we just know that to be true. I am showing this, so I know where it's coming from, but that's a totally optional step. And this was in centimeters, and centimeter is always something squared, 7 squared centimeters. I think that's enough problems for us today. If you have troubles with something, call me. Remember that my phone number is 909-985-7756. I prefer that you call during school hours, but if you can't call during school hours between 8 and 3, call me in the evening. Just don't call me past 8 o'clock. My husband's not happy with phone calls past 8 o'clock.